Good morning, Tamina Khan is here in TKMaths is fun. Today video is in continuation of the lessons on A-level mathematics M1. In this video we will focus on friction. Basically I have made 3 videos on this topic. The first video, which is this one, is on the cases when object is on the rough horizontal surface. Next video is on the objects which are on the inclined plane and making certain angle with the horizontal. And the last video is on the word problems. So let's see what is friction and coefficient of friction. Suppose you have a rough surface and an object on top of it. The friction force is in between object and rough surface, and it acts to resist the motion of the object across the surface. So if force is applied here in this direction, now force could be one force or it could be two forces, maybe one horizontal force and one force is acting in certain angle. So there may be multiple forces, but frictional force will be acting in the opposite direction. Let me give it a name, force P1, force P2, and this is my resistance force, frictional force, right? The frictional force will be in the direction opposite to the motion. So if motion is happening in this direction, the frictional force will be acting in the opposite direction. One very important thing, the maximum friction, let me write here, the maximum friction is measured by mu r, where mu is the coefficient of friction and r is the normal reaction. We have seen this in the previous cases, and how to calculate it, we have seen that also when multiple forces are applied on the object. But in all those cases, the surface was smooth. Now we will focus when the surface is rough. So this is called coefficient of friction, and if you manipulate it, it will become maximum friction divided by r. So coefficient of friction is basically a ratio and it has no dimension. It has no units. Now another important thing, if the object is at rest, then this frictional force may be maximum or it will be equal to the forces were applied on it. For example, the forces applied on the object to make it move are 2 Newton. And the maximum frictional force is, for example, 6 Newton. Then in the case when the forces are equal to 2 Newton, then only 2 Newton frictional force will be applied to keep it on rest. Maximum frictional comes when the object start moving. So for example, there is an acceleration of 2 meters per second. It means object has started moving. In that case, the maximum frictional will be acting on the object. And there is another thing which is called limiting equilibrium. Limiting equilibrium means when the applied forces on the object are equal to the maximum frictional force. In that situation also, the object will be at rest, right? So now let's start. One more thing just for your information, friction forces are of different types. For example, I have written here static, sliding, kinetic, resistance, internal frictional, and there are different ways to measure the coefficient friction for these. So our focus is on these two in our cases. So I'll start solving this problem, which is on the horizontal surface, and the force applied on it is 20 Newton. And the coefficient of friction between the body and the plane is 1/7. Frictional force is mostly between 0 and 1, but there are cases when it is more than 1 also, right? So in our cases, mostly it is between 0 and 1. Okay, so mu is equals to 1/7. And we have to find out either object will remain at rest or it will accelerate when the force 20 Newton is applied on it. So we will try to find out the maximum frictional force and we will compare it with applied force, which is 20 Newton. If maximum frictional force is less than 20, then object will accelerate. Of course, it is less to resist it, but if it is equal to it, then we will say it is at rest and it is at limiting equilibrium. limiting equilibrium. Then we will say it is accelerate. But if maximum friction is greater than 20 Newton, then we will say object is at rest. Okay, so let's see the maximum frictional force. We know the maximum frictional force is equals to mu r. Mu is given to us in the question, but r we don't have. So we have to calculate r first. Okay, r is a vertical force, normal force, which is between the object and the surface, but at the same time there is another force, 28 Newton. It means the vertical forces are equal to each other. So to calculate r, I will put upward forces equals to downward force. So it will be equals to G we will take as 10, or let's take it 9.8, but in your exam you will take it as 10, you know that, because in 9709 paper it is 10, but in a Dexil paper it is 9.8. So depending which exam you are giving, because this topic is a part of A-level mathematics of different British boards, so you can use the value of G accordingly. So suppose I am using here 9.8. Okay. So now it will be 98 minus 28, which is equals to 70 Newton. Right. Now this value of R you will plug in here, and it is equals to 10 Newton. So now you can see the frictional force, which is mu R, is equals to 10 Newton, but the applied force is 10 Newton. So you can just write object will accelerate. Why? Mu R, which is equals to 10 Newton, is less than 20 Newton. So you will write object will accelerate. So one question I have given here for you, and you will solve it and I will show you the solution. I have taken the case here where force is applied at the angle of 45 degree. Because in the previous videos we have seen how to resolve forces, so that's why I've given it to you to check your understanding. So you can put the video on pause, but I'm showing you the solution here. Okay, so we have seen the if maximum frictional force is greater than forward force, and forward force is here, it is this line acting in this direction, right? Then object will remain at rest, otherwise it will accelerate. So let's see here. So by resolving the forces, we know forward force is 56 times root 2 cos 45, which is equivalent to 56 Newton. And we will calculate R. In this case, the upward force is 10 Newton, but the downward force is 10 G and 56 root 2 sin 45. Please remember, this is a common mistake made, that the student forget to add this as a downward force. So in this case, equation will become this, and you will calculate R, which is equals to 154. Now this value of R you will plug in to calculate the maximum frictional force, and you got the answer 22 Newton, and your forward force was 56 Newton. So forward force is greater than mu R, so of course the object will accelerate, right? So now let's see the example number 2. In this case, you have to find out the coefficient of friction. So formula will remain same, everything will remain same. Manipulation of subject we will do here. So according to Newton's second law of motion, because now object is accelerating, you can see here. So you have resultant force is equals to ma, according to Newton's second law of motion. So now if you resolve it here, let me change some other color which is obvious. Okay, if I resolve it here, this is the forward force and this will be the upward force. I'm resolving it. So this will be 40 cos 30 and this will be 40 sine 30. So now if I see here, it will be 40 cos 30 minus maximum frictional force, which is mu r, equals to ma, right? Mass is 5 kg and acceleration is 3. Now 40 cos 30, let me keep it as it is right now. So what do you see, what is missing here? Mu I have to calculate and r is not given in the question, that also I have to calculate, right? So let's keep it r also here, and this is 5 times 3 is 15. So now you need to calculate r here, which you will plug in here. So let's calculate it first. I'm calculating it here. So r plus, so upward forces are r and 40 sine 30. Right, it is here, you can see the arrow is acting upward. And the downward force is weight, 5g. Okay, so r is equals to 5g. Like I said, I'm taking 9.8. You will see according to the requirement of the examination board. Is it 40 sine 30? It is equals to 29 Newton. So this value of 29 I will substitute here. So by the way, I'm just writing 40 cos 30 because I will put it into calculator later. But if you want to write it down at this stage, you can, right? So it is equals to minus 15 equals to mu and r is 29. Now you can use calculator and you will get mu is equals to 0.677. No unit because it is dimensionless. It is a ratio. So I hope you understood this question. So let's move on to the question which is to test your understanding. So again, I have taken here one question, but now this is straight horizontal force applied. In the previous one, it was applied at certain angle. So according to Newton's second law of motion, F is equals to ma. And just like forward force is 10 Newton, backward force is mu r, because when object is in motion, the maximum frictional force acts on the object. So now to calculate r, we will equate the vertical forces. So r plus 29 is equals to 5g. And this value of r you have plugged in here. And you got your coefficient of friction, which is mu, 1 over 4. Now let's solve this question. Whenever you will see the word problems, mostly in mechanics, they are very long to create the scenario. So you have to break down information slowly. So let's start doing it. And this is the last question of this video. So first of all, the coefficient of friction is 0.25 given to us in the question. Let me write it here. What else is given? A constant horizontal, now this is important, constant horizontal force is applied on the body for 5 seconds. So for 5 seconds it is applied and then removed. Okay. So if this is the scenario here, object started moving from here because initially it was at rest. So this is the object and the weight is 1 kg. It is at rest, u is equals to 0. And then for 5 seconds it was moving with the force applied on it and then it was removed, right? So this is the forward force which was applied on this. Okay, and because it was on the rough horizontal surface, there is a frictional force also. So I can write F maximum frictional force. Given that when the force is removed, the body has a velocity of 3.5. So at this point, the velocity was 3.5 meter per second. Let's start. There are 4 parts questions you have to answer. Find the acceleration of the body when experiencing the applied force. So in that case, we will apply constant acceleration formula. So it is part 1, v is equals to u plus at. Okay, so v is 3.5. We are finding out the acceleration within the time of 5 seconds. So it is 3.5, u is equals to 0, a we have to calculate, and time is 5 seconds. So a is equals to 0.7 meter per second square. Right, part number 2. The magnitude of the applied force. Now this is forward force. I have to calculate this. So now we will use Newton's second law of motion. Right, resultant force is equals to ma. So forward force minus mu r, because that is the maximum resultant force in action now, and mass is 1 kg mean 1, and acceleration is 0.7. So you have to apply the forward force, which is this one. Mu is 0.25. You can see it is given in the question. And r in this case is equals to what? Here. So if you see, it is equals to only this force. So r is equals to 1 g, and g is 9.8. I'm taking it, right? So forward force will be 3.15 Newton. Third question is the retardation of the body when the force is removed. Now situation is same, but this forward force will become 0. So of course the acceleration will change now, right? So what it will be? That is, we have to calculate. So again, I'm writing exactly the same situation, picking it up from here only. So it will be 0 minus mu r is equals to 1 times a, mass times a. Mu is 0.25. R you have taken as 9.8, just like previous case. And you will calculate the value of a, which is minus 2.45 meter per second square. Right. Now the last part is saying calculate the total distance traveled by the body. So now if you look at this situation, what happened? Till here, in 5 seconds, the velocity was 3.5 meter per second. After that, the forward force removed, object is started decelerating, and then definitely it will stop somewhere. So we have to calculate the distance covered in this time period and in this time period. For the second stage, your v will be 0 and your u will be 3.5. And for the first stage, u is 0 and v is 3.5. So we will use these values in our formula. So let's see. So in the first stage, I'm writing here the distance covered in 5 seconds. Distance covered in 5 seconds plus distance covered when force is removed. Okay, so now for this part I'm using the formula S is equals to ut plus half at square. So I will calculate the distance from here, and in the second part I'm using v square is equals to u square plus 2as. So I will calculate these two distances and then I will add them up. Okay, so in this case the distance is initial velocity was 0. You have seen in the first part initial velocity was 0 plus half, and acceleration we have calculated 0.7 and time is 5 square. So if you calculate it, it will become 8.75. And in the second half, if I see, v was 0, initial velocity will become 3.5, right, square, and acceleration was negative, which was minus 2.45, and s you have to calculate, right? So in this case, let me see the calculator. The distance is coming 11.25. Let me just check one more time. 3.5 square divided by, yes, it is coming 11.25. So now these two distances you will 2.5, sorry, 11.5 is the total thing. It is coming 2.5. 2.5. So you will add up these two distances and you will get the total distance, 11.25 meter. So I hope you understood the question. And in the next video, we will see all these situations when the object is on inclined plane, rough inclined plane. Thank you very much for watching the video. Please press like and subscribe button and share.